Okay, well, let me tell you about this case study.
Yes.
It occurred to me that while it was fresh in my mind, it'd be useful to both of you just to see what the pieces are, because some of them may surprise you about what's required. So I'm going to share my screen. Here's the essentially the local copy of the repo for GlowScript. And just wanted to kind of remind you what the major pieces are. An important piece is the lib folder, in which there is the Glow folder, which is where you find the JavaScript programs for implementing boxes, etc. Okay, so that's, and primitives is absolutely key. And we'll be looking at that. Primitives is the thing that contains the code for making boxes and cones and now attaching lights to those objects. WebGL renderer is the piece that actually talks to WebGL. So there are JavaScript comments in there that are basically WebGL calls. And the other important thing in this region is we come back up out of that glow lib. There is a compiling in lib, is this compiling thing, and GS compiler is the thing that takes your Python code, passes it through RapidScript, and puts you into the program to run it. And that's really saying very little, because there's much more in this compiler program than you might expect, because it sounds like you just call RapidScript. But as I think you actually do know, that's only a piece of it, because I have to do a lot of pre-processing before handing the code to massaged Python, hand to RapidScript. And then when I get back from RapidScript something, I have to do further work, in particular to prepend async to user functions, and to prepend await to calls to those user functions. So there's more going on there than just calling RapidScript. That's all I really wanted to say about that. I should just mention what some of these other major folders are. The shaders folder contains actual shader code. So this is GPU code. It's its own language. I never remember exactly the name of that language. And that has not been touched for many, many years, until very recently, when I went through and fixed them up to handle up to 32 instead of what had been an arbitrary total number of, I think it was 8 lights. So I had to go through them recently, but that's the first time in a very, very long time. Oh, and also it's bringing it up to WebGL 2. This code had been WebGL 1. Those are really quite minor changes, but they needed to be made.
Are all the browsers using WebGL 2? Did that just sort of happen?
They're available essentially everywhere, yes. There was, you may or may not remember that recently there was a little panic when I think it was, it was Tom Moore. Stuff stopped working on his Apple, but it was because he was using a very old version of Safari.
Yeah.
and then Steve found that there was a way to turn on access to WebGL2. It was just normally off.
Yeah.
So that's another major piece here. Package, if you look here, you'll find stuff going way, way back. These are the various major compiled files for the libraries. And it's the reason why you can still run a 2.2 program, because we keep all of them. And let's see what else here is possibly interesting. This is the offline version. You can run offline, and then there's a lot of these files here have to do with making builds, which is basically taking a bunch of these files and putting them together and minimizing them to produce things like
the min versions, yeah.
Yeah, these files, minified. Okay, so that's the basics of what's there. And I'm going to emphasize start with the primitives and just show the code for attach light, explain how that works, but then importantly show you what more there is to do after you are in that, because there's some places that you have to touch up. The compiler, oddly enough, needs to know about this attach light function, because it has to know that it should not prepend a call to attach light with an 08. So there are cross connections here that are not entirely obvious. And there's some documentation along the way to help somebody who would just take it over cold, but still, so that's why I'm exposing this to you all. So let me change where I'm sharing.
So one question I have,
Yes, please.
is so normally when you use async and await at the root level, at the highest level of async, when you call that function, it actually doesn't return what it appears to return. It returns a promise that you need then to call the then or the accept method of that promise in order to so
that was what you had originally. That was all we had originally, was that style of things, getting a promise and dealing with the promise and all that stuff. But in fact, now in JavaScript, you can just set up a wait and it just doesn't return. And when it does return, it doesn't return with a promise, it returns with the actual return stuff.
So that's the way await works. I understand that.
Oh, okay.
But in order to use await in a function, it has to be an async function.
Correct.
And somebody is going to call that function. And if they don't call it with await, then it's going to return a promise.
Which is why
You see,
I take your Python code and I stick in those awaits and asyncs for you.
so, but somewhere it can't be turtles all the way down. Somewhere somebody has to deal with the promise. Do you see are you dealing with that, or is that happening in the compiler, or?
That's just handled by modern JavaScript. So there have been major improvements to async and await.
I understand that, but unless
I'll put it this way: if I don't put in the await, what I do get is in fact a promise.
A promise, right? Yes. So I guess my question is, so in order to use await, you have to have an async function. In order to get the whole thing working, somewhere somebody
there has to be an
async.
Your entire program I wrap within an async.
Aha. Okay.
So that's the foundation.
Okay.
Yeah.
So basically, you're returning a promise at the highest level of JavaScript, but nobody's awaiting that. Nobody cares about that because that's the root of the whole thing. Okay. Yeah, that's what I was curious about. Okay.
Yeah. Now I understand now why you were asking this question, but yeah. So if you can see it yourself, if you just do, export your program and look at the export JavaScript, you'll find up at the top in async.
Okay. And then when you, and you're invoking that in the application, the web application that runs the GlowScript program in the web page, and you're not bothering to do anything with the promise that gets returned from that async. It's just running the program and nobody cares. If, in fact, it may never return, right? It may never return.
And by the way,
Yeah, okay.
I'll comment that to my, when the guy who supported Streamline, which was originally used by Share in order to deal with calling functions that had to wait before returning. Streamline produced very complex code, but it worked. But it was no longer being maintained because, and I think it was the guy who made Streamline who was instrumental in this, that came into JavaScript the capabilities of async and await. And so I was the one who changed over to using that rather than Streamline.
So I'm sorry, I distracted you from your main point. I apologize.
It's okay.
I thought,
no, I expected some of this would come out exactly in this way too, because there is so much interconnection here. And in some important sense, this code base is not very clean because there are, I think, necessarily many different kinds of cross connections. So, for example, I gave one already. You wouldn't expect that introducing a new attached light function would mean that you have to change the compiler, the transpiler. I mean, what? What has that got to do with what? But it does. And also, when you implement this, why do you have to make a change in the renderer? I mean, we already make lights and things, so what? Okay. So to be continued here. And so what I want to do next is look at the actual code in the primitives.js. Okay, so you should be seeing a function here, attach light. Mm-hmm. Yes. Okay, so we're in primitives.js, and in this file you'll see the creation of box and cone and so on, and those are actually classes. At the time that Share constructed and refactored everything in 2011, JavaScript did not have class. But when you called something with a new prefix, it behaved like a class, basically. Weirdly, JavaScript now, 10 years later, does have class, but weirdly, you still need to say new when creating an instance of a class. I mean, that just seems wrong. Never mind. So here's this is new code we're looking at. Just for comparison, here's a somewhat older attach arrow. Well, it is an older attach arrow, and there's some similarities between the two. This thing, attach light, is not a class. It's a factory function. That is, you look down here, there's code. Now you set here, let A equal local light. So it's calling a thing that is a class, a thing which has a color attribute and that's the main thing it has, and a position. So it when you now call attach light, what you're getting is actually a local light, but it's an augmented local light. In addition to its standard attributes of color and position, it has an option offset. So if you just make a local light, you don't get an offset, and you wouldn't do anything. But this thing, it's an augmented one. Similarly, when you say attach arrow, you don't get an attach arrow object. You actually get an arrow object, but it's enhanced. It has additional attributes that an ordinary arrow doesn't have. Okay, I made the point. So if you look at attach light, the structure of this is very similar to any of these object codes, if the nature of when you call it with some object, like a box that's moving or a sphere that's moving, with various options. And so if O dot position is undefined, throw an error. You can't attach a light to an object that doesn't have a position attribute. And if options themselves are undefined, well, create an empty object literal dictionary. Make an option __obj, which is the box or the sphere that you gave me. Make this local light not be pickable. Figure out what canvas this object is in, for reasons you'll see. And if the options dot underline, options dot offset, if you don't specify an offset, then we make a default offset, namely the local light will be at the position of the moving sphere at all times. Okay. And a local light has a position, so we'll add the position of the object, add to that this offset. And notice we cannot say here O dot position plus options dot offset, because there is no operator overloading in JavaScript.
Right. So this is JavaScript, not Python. Don't forget.
Yeah, we're absolutely in JavaScript here. And also the offset better have an X component, and showing that it's a vector, otherwise we'll complain about that. Pick up, if options dot color is undefined, set the color to the same color as the object that it's tracking. And with that, we now create a local light, but as I say, it's an augmented local light. It has these extra things, namely __obj, so that we know this light goes with that object, and an offset.
Is it the presence of that attribute that allows you to then make the light follow the object around? Because
yes, and that's what we'll look at next.
You detect that, hey, there's this attribute here, so this is not just a regular light.
Yes, okay. And in particular, note this penultimate statement here. For this canvas, for the canvas in which the moving object is located, there is a list of attached local lights. And we're going to push onto that list this particular augmented local light. Okay? Now, so what? Well, the so what is seen here in WebGL_renderer.js. This program is called roughly 60 times a second. It calls itself. You call it once and then it keeps calling itself. But of course, how often it really gets run, it may not get to run 60 times a second if you're taking more than a 60th of a second to do processing of making lots and lots of compounds or whatever. But we are now in that, and for every canvas that you have, there is an associated WebGL renderer object. So if you have 3 canvases 60 times a second, we will call WebGL renderer 3 times with the information for that canvas. So here we are in this renderer package. And this is the key answer to your question, Steve. remember that we made in CVS has been set up here as the canvas for this running of WebGL renderer. Remember, we pushed onto that list, that canvas, that list, we pushed the augmented local lights. So what we pick up is that local light and its position. So we want to reposition that local light where? Well, we pick up for that object, let's say it's a sphere, we pick up a sphere. The sphere has lots of attributes, position and color and what have you. This sphere, well, they all have them. It's only these that are going to be affected. One of the attributes of a sphere can now be light in the world. Well, what that is that, so here's a bunch of the functions, attributes and functions, methods of boxes and spheres and what have you. And there is this new thing, light in world, which is associated with attached light. We pick up, so we're calling this as an attribute of the sphere, and it has an axis, an up, which if we cross those two, we'll get a third direction. And now we have a 3D, basically an XYZ coordinate system tied to the moving sphere.
Right.
And we pick up the components of the offset, which is part of that local light. And then we create for the sphere, this, we return its position, we add the x-axis times the other x-axis, and the similarly for y and for z, and the effect is that we figure out the actual direction of the light relative to the moving object and add that to its current location. Okay? So this is basically just about everything that happens in the GlowScript library. And I think we could still continue to use the word GlowScript when talking about the underlying stuff that we're looking at here, which is not exactly what people are writing themselves. Okay, so the one remaining thing is, I hinted at, is in the compiler we have to do some things, which seems very odd, but let me just search for, let's see, yes, attach light. And here, for example, here's a list, a constant list of the VPython objects. And you'll recognize a box, compound, cone, color, all these words. And I'll say in a moment what that's for. And I go forward to another reference to it. Here's another one. Here is a no-await list of things, which includes not just our things like sphere, but also basic things like tangent, or for that matter, what's a good example? Well, round, say. Both of these lists have to do with the fact that we have to figure out who needs a weight. And we want to avoid putting awaits in front of things that shouldn't have them, because it takes extra time to process them. Happily, I'll mention that I was entranced that when I first started working with async and await, I naturally did some timings to see could we afford to use such things. And it turned out that the penalty was very low. I think it was like a 20% slowdown of computational code. So it just didn't really matter. It's almost as though you could afford to make everything await and you'd still have good performance. But it seems better not to do that. So I have these two lists, which are used in kind of two different ways in the processing of the compiler. This is the post-processing part of gscompiler.js. So we've already called RapidScript. We got RapidScript to do its job. And this comes after that. Any questions on that? But
so I guess.
Yeah, Steve.
Yeah. So the thing is, after RapidScript has done its job, you can't tell the difference between functions the user created using a def in their program and the functions that already existed in JavaScript or that the user didn't define in some way that already exists someplace else. So
however,
that's why this, oh, go ahead.
During the pre-processing, before handing stuff to RapidScript, I do track and make lists of the Python functions, classes, and class methods that I've encountered.
Okay.
And so I use that information as well.
Okay. So I wondered if, I was just curious if it might be easier, rather than keeping track of all the functions that don't need an await, to enumerate the functions the user has created that would require an await, but maybe it's 6 1/2 dozen the other.
I'm kind of doing both.
Okay.
As it works out, as it plays.
Okay.
Out. It's conceivable that it could be either this or that, and maybe I just backed into this scheme. There are some traps in the sense that I think that what I've done is not perfect, in the sense that if you go around making lots of classes and methods and functions of your own, where you deliberately choose to use names like sphere or something. Then...
Oops. Yeah. Oops. Yeah. We would never do anything pathological like that, right?
Exactly.
Our students, on the other end.
Yeah, right. Okay, so
although I have to confess to redefining PI on a regular basis.
Yeah. It's very tempting because of the initial momentum.
Exactly.
Yep.
Because it needs to be P_I for you, Aaron. There you go.
That's right. Yeah. You know what? That's not a terrible idea, to make the variable pi maybe a uppercase P, uppercase I. That's or make it a function.
Or make momentum
everybody.
capital P.
That's a good point too.
So I think I've completed the tour of what happens in the GlowScript environment for what's involved in adding a new functionality.
I do have
sort of typical.
I do have one question, and I think I actually encountered some of the things you're talking about back when I was trying to add the ability to analyze a graph using Plotly. I remember playing around in some of these files. One of the things you showed, and this is a very, very minor point, but when you were talking about I think it was the attach light function, and you add the offset to the position of the object, I think, and then after that you check that it's a vector. It just made me wonder if you should check that it's a vector before you add it. I don't know if you remember that part. But you throw an error if the offset is not a vector. But right before that, you actually add it to another vector. So it just made me wonder if maybe it would throw an error already when you try to add. I think it was where attached light was defined. It's a very minor thing.
Yes, let's see.
So one might be tempted to swap the order of those statements if that's
Yeah.
Okay, so now repeat your question.
So line 2713 and line 2714.
Yes.
I wondered if those should be switched because you add the offset to a position vector before you check that the offset is.
Yes, that is wrong. Yep. Yeah, I found a mistake here that I fixed, and in the process, I think I broke that. Good eyesight. I will fix that. Okay, I had made a similar mistake here, but I missed this one. Okay, so next I want to show you what happens. How do we now get this added to the Python 7?
right.
But are there further questions or error corrections or?
No.
Okay, all right. So now let's go to VPython.py, which is obviously the central piece there. I guess it's worthwhile reminding you of what this other thing looks like. Okay, so here is the local repo for VPython 7. And it's in the VPython folder that is the kind of the most important files in a certain sense. In particular, VPython.py, which is obviously a Python program, which talks to things in the VPython libraries. In particular, in the VPython library, there is a copy of the GlowScript minimized library. Actually, it's not exactly the same copy. It's built in a slightly different way to not bother bringing in some vector stuff that is not needed in VPython 7 because VPython 7, VPython.py can do operator overloading for vectors. So in the vector class, in fact, Ruth and I siphonized it for speed. So this particular glow.min is something you'll find in the GlowScript repo. It says something for installed Python, and that's how it differs. But we're going to look at glowcom.html or glowcom.js, which are the JavaScript programs initiated by Cody that the Python program talks to. So that's just a reminder what the pieces are. And now I'll go back to here. Okay, so here we're in VPython.py. And you know that because we're seeing defs rather than functions. But it is a factory function. So this is, here you see an attach arrow, class arrow, and so on. So this is the central program in VPython 7 where you make all this stuff. By setting things up here in Python, and you have to track some things here, but you also send instructions over to the browser where there's code that we'll look at for actually driving things. And what's over there is basically, it's a GlowScript program. It doesn't itself make spheres. It calls on the GlowScript library to make a sphere. So it's a very unusual architecture. But what I had to do to make attach light work here was, first of all, I had to screw around for many days, making a million mistakes, going off on completely wrong tracks, doing things that didn't make any sense, and I couldn't get them fully to work until finally I realized, oh, yes, it's like attach arrow. In fact, it's like attach light, as a matter of fact. Namely, what we're going to do is we're going to have a factory function which returns a local light with special attributes. Sound familiar? So in fact, this is very similar to what we're talking about. And again, the syntax is going to get an object from you. It's going to get a dictionary of attributes. If the object's position isn't a vector, we raise an error message. If color isn't there, if color is there, it better be a vector. If not, complain. Otherwise, make by default the color be the color of the object that you're tracking. If offset isn't there, if it is there, it better be a vector. And otherwise, by default, make the offset be 0. And here is the key point. Let's make a local light, but it's an augmented local light. And it's embarrassing how convoluted this was until it got to this, which you can appreciate is very, very similar to what you saw on the GlowScript side, right?
Yeah, so you're not actually going to call the GlowScript version of attach light. You're basically reproducing that same procedure at the Python level. Is that the idea?
Yep. I let it do the work for me. Being lazy. Now, there's one interesting thing here to show you. So first of all, we're gonna call here in this Python file, we're going to say, make me a local light and call it A and return it. And this local light has a position. It has a color, but it also has an offset. And it has to refer to the object. And it refers to the object in a way that is unusual. And this is due to Cody when he originally set this all up. So you can't pass from this Python program over to the JavaScript code in the browser. You can't just pass the stuff there. You have to, you can't send a this for the sphere that's moving. You send an index. So what his code does is every time you create another sphere or box or cone or whatever, you increment an index, which throughout the code has the name IDX. And every object has, as an attribute of that object, it has an IDX. So on this side, you typically don't use it directly, but on the other side, it's how you get at stuff. So at some time in the past, you'd made a sphere and you told the browser side to make a sphere. It dutifully incremented its own index, or actually we sent it an index, but it adds it to its own list. And over there, whenever it needs to reference a sphere, it's by that index. Okay, makes sense.
Yep.
And so
you've got a big dictionary or a array or something on the JavaScript side that has, it's like a lookup table for all these objects that have been created. Yeah.
Yeah. And it's not a lookup table because I think it's a linear list. So there's no internal searching, I think. So that's the basics for this. And I think that's all I need to say about this, but we're not done. Because we need to, these are, offset is not an attribute that this machinery ever had. So we're going to go up to the top of this file, and near the top of this file, first of all, you'll see a list of names of things that can be imported here, and that now includes somewhere
Dash
here.
light. Second row.
Second, yeah, there it is. Yes. Okay. So the name got added there. More interestingly, there's encoding and decoding at the other end. Cody did not do this. We did. Ruth and I did this stuff here. We take your command that has its attributes and so on, and we say, okay, we're gonna send it. We're not going to send. Let's see, let me find the thing itself. We're not going to send offset itself over there. We're going to send the letter capital K, and we're not, and attach IDX. That's the ID of the moving sphere, and that was not a thing either. So there's that, and we also had to list offset as a vector. So part of the encoding machinery here just needs to know what kind of thing it is to set up stuff that's essentially JSON to go over to the other side.
And the reason for the encoding is simply to save
yes, because
data.
There's so much data being sent, and it's expensive. Yeah.
Whenever I was working on the additional feature for graphs to be able to highlight an area of the graph and get or highlight a region of the graph and get the area under the curve and so forth, I was having to modify all of these areas of the code. So it looks familiar, even though it's been probably 3 or 4 years since I looked at it.
Yeah.
It's all coming back to me. Interestingly, we were just using the code I had created this semester, but I never had it at the point I was comfortable submitting a pull request to put it back into the main library. It needs a lot more testing, but we're using it all the time. So
that counts.
It's useful. But all of this is coming back to me. But it's familiar, but it's been a while since I looked at the details. So it's helpful.
So let's look now over at Glocom HTML. This happens to be, there are 3 versions of this browser program. One for if you're using, say, Idle or some other launcher, that's this one. There's another one if you're using Jupyter Notebook, and there's a third one if you're using Jupyter Lab. Okay, there's 3 different flavors of the thing you're talking to at the other side. And so, of course, on the Python side, you have to figure out which situation you're in. We do that. Here, remember we were making a local light, albeit enhanced. So we come here, we're down having decoded. So here is the processing of local light. Because remember, that's what it is. It's augmented local light. We create a local light. Notice here, glow objects is a thing into which you can index to pick up an actual object. And so this is how you operate between knowing an index and knowing a this. Okay. If there is an offset, then set up the machinery for that, in particular, pushing to the canvas attached lights list this particular object. But anyway, that's all there was to it to get that stuff working on this side. And if I'd seen it more clearly at the beginning, it wouldn't have taken me 3 days or 4 days or whatever it was of wandering around wilderness. Let's see, did I miss anything? So
once it's in attached lights on the JavaScript side, then the machinery you have to update the light position and everything 60 times a second in the renderer or whatever just works because it's in that list.
Yeah. And what else is there to this? Not very much, I guess, other than me. I should update this machinery.
And CFG is that's the de-JSONified version of the object that came over from the other side.
Yeah.
Okay.
And in fact, if I do a search for function handler, I want to show you something very useful. If you get rid of these, if you uncomment this little section here, the effect is that it will display for you an un-JSONified, a stringified presentation of exactly what messages got sent to you from the Python side. This is extremely useful for debugging. And it's sort of interesting also to see what it looks like.
There you go.
It certainly does. As you know, Ruth and I did many months of pair programming, taking Cody's initial work and making it harmonize with the newer syntax of the GlowScript stuff. But we owe him a huge debt for putting that together. And the basic architecture is still there. Although recall that Matt Craig did at one point refactor things. And usefully. There is one refactoring that somebody should do, probably I should do it, is that I mentioned that there are these 3 different glowcoms. And so Spider, Jupyter Notebook, Jupyter Lab, 2/3 of each of those files is exactly the same. And so the refactoring, that should be put in one place. As it is, I had to manually compare side by side and make the changes to make sure they were all on the same boat. So that is a refactoring. This definitely should be done. What there is now is there's a bold thing that says from here to the end, this is essentially the same as these other files. I think there is maybe in the Jupyter Lab one, I think there might be one place where it's different, but that could be handled by an if.
I did notice as you were showing the file system, a file qtbrowser.py. I think that goes back to my experiment in using Qt to pop open a Python looking browser window so that it more mimicked what you got with VPython Classic. And it's just been a few years since I first did that. It worked great when I tested Mac and Linux. And of course, after submitting a pull request to Matt Craig, and I think he merged, I only found out that it didn't work in Windows. So that was my one attempt at contributing to the VPython repo, and I nearly broke it.
That somehow reminds me, because you mentioned Matt Craig, it's this, that I don't know if you followed this, but I had difficulties updating the VPython 7 repo. And it was because in his code, he didn't have the name attach light, and therefore all of the tests failed. So I didn't have any notion that implementing an additional function in python.py would break his test programs.
Yeah.
And it failed all 16 tests. And so he had to go in somewhere and add that name in order to get through the tests. So there's another one of these interconnections. There's a lot of lore. My inclination is to think that the reason it's so complicated is that it's actually pretty complicated. And it's not clear to me that one can get around these issues, because there are links between the GlowScript code, the VPython.py code, and of all things, and WebGL, and Matt's tests. Well, that's four separate things that necessarily have to be separate, and they. I guess in some wonderful world, one could imagine a really great build that would somehow magically do the right thing. And it's still the case right now that I'm the only one positioned to make new versions of glowscript.org, because the making of those minified files is a Python program inherited from Share, which doesn't run in Python 3. So I still have a Python 2.7 that I use for that. And when I tried to modernize it and get it to work in Python, I failed. I couldn't get it to do it. And by the way, it uses Node for your greater pleasure. Ouch.
And actually, and when I was working on the source, I encountered all the things that you just mentioned, that I had to modify the JavaScript, and everything worked in the JavaScript. So when you're working in GlowScript, you can get a new feature working fairly quickly. But then, of course, that's only part of everything you have to do. You now have to go back and implement it in Python, which, as you showed, is a separate implementation. And then you have to get the communication working, that piece, and then and as you mentioned, you also have to minify. Once you have the GlowScript working and things, you have to minify that and put that in your VPython in order to test on the Python side. And so it really is a quite involved process with a lot of different pieces when you want to add even a single new feature. Or
the individual pieces seem to be okay. Ruth has commented that maybe primitives.js should not be as long as it is. It has essentially almost all of the objects, except for I think the machinery of extrusions and 3D text. And she might be right. It's not obvious to me that's broken, though. But yeah, it's necessarily complicated, I think. I should mention too that for the most part, with the one exception being, I think, the MathJax. I think MathJax is called from some remote repository that maintains stuff like that. But almost, and maybe all of the other things, including RapidScript, I have my own copies, so that if support were to stop, we could still keep going.
Mm-hmm.
So let me show you the fruits of this labor. Here's a simple program: make a box, make another box it's basically a floor underneath, attach a light to the box that's named B and give it an offset and a color. And then here we're just going to move this box across the screen. If when we pass x equals 0 and the color is cyan, change the color and change the offset to be trailing instead of leading. And what this looks like is quite pretty. You can see that there's a light above the floor, and now it's
Neat.
trailing behind, and it's pretty nice, huh? And here's another example. Here, well, actually, back up one moment to say, here's a floor and a ball, and
I was going to ask about that.
Right here.
If you don't put an offset, it becomes luminous. The object itself becomes luminous like this, right?
No, you have to also, since the light is coming out, WebGL is not going to illuminate the outer part of that sphere.
Okay.
It will illuminate things in the neighborhood. So what you do is you specify emissive equals true, and then it glows.
I see.
And
but there is actually a light embedded in it.
There's a light embedded in it right here.
Right. Yeah.
Right there. Okay.
Yeah.
And
because
so
there's no offset. Yeah.
So
Nice.
What you see is it's got an attach arrow and it's got an attach light.
Oh, wow.
Isn't that
That's
awesome?
Oh, wow.
That is awesome.
That's fantastic. That's that's just too pretty.
So now when we have two stars orbiting one another, we can easily
Yes.
we can put a shiny.
And you can have more than one attached light. You have multiple attached lights if you want to, for whatever reason.
Nice.
Attached light, attached light. They can all be attached to the same object. No reason not to.
That is really fantastic.
That's awesome. Cool.
Yeah.
Just as you can have multiple attached arrows. Show the momentum and the force in an orbit, for example.
That does make you want to create a star and planet where you get a reflection off the planet, which affects the light curve that you get from the star.
There you go.
That's fantastic.
Well, thank you very much, Bruce. That was great.
Well,
I really
thank you for
appreciate it.
coming.
Yep.
Thank you.